To us humans, Earth is quite large. It takes days to travel from one side to the other. But once you leave Earth, it quickly becomes clear we are actually living on a tiny speck in a vast universe. A universe filled with billions of planets, billions of stars, and trillions of galaxies. The cosmos operates on a scale so immense that can we truly comprehend it or fully explore it? Yet within this vast universe, there are things that, on their own, shatter our sense of scale. Stars so massive that even the sun looks like a dot beside them, and deep within the southern constellation of Scutum, we may have found the largest one yet. So just how big can a star get, and can we discover even bigger ones? I'm Carl. Welcome to my channel. Join me as we embark on a cosmic journey into the realm of the universe's giants. You might think our sun is big, and yes, it truly is. Its radius is about 710,000 kilometers. If the sun were a ball, the Earth would be 110 times smaller, about the size of a 2-millimeter grain of salt. Even if you combined the mass of all the planets in the solar system, the sun would still be 743 times more massive than all of them combined. But when we look at other stars, the sun is not that big after all. Our closest neighbors, the Alpha Centauri stars, are similar in size, while Sirius A is twice as large. So how big can a star really get? To understand that, we need to look at stellar evolution. Our journey begins at the heart of the Hertzsprung-Russell diagram, developed independently in the 1910s. This diagram compares the temperatures and brightness of stars. Running through its center is a band known as the main sequence. Most stars spend the majority of their lives here. This is their most stable phase. Hydrogen fusion occurs in their cores, pushing energy outward while gravity pulls inward. This delicate balance is called hydrostatic equilibrium. Our sun sits right in the middle of this diagram. In other words, it is a fairly average star. Its surface temperature is about 5,778 Kelvin, which is why it appears yellow. Every second, it converts about 600 million tons of hydrogen into helium, and this energy sustains life on Earth. But as we move upward in the diagram, stars begin to change. Hotter to brighter, brighter to usually more massive. For example, Bellatrix, 4 times hotter than the sun, 8.6 times more massive, about 200 times larger in volume. But this comes at a cost. Massive stars live fast and die young. While the sun's lifespan is about 10 billion years, Bellatrix lives only tens of millions of years. So are the biggest stars also the most massive ones? Partly, but not entirely. It is believed that stars above about 150 solar masses become unstable and tear themselves apart. But the universe has a way to cheat this rule. When 2 massive stars collide and merge, they form an even more gigantic star. One of the most extreme examples is R136, A1 265 times the mass of the sun, 40 times larger in radius, extremely luminous. Yet even this is not the largest. The true giants appear near the end of a star's life. When hydrogen runs out, the core collapses inward and helium fusion begins. This process causes the outer layers to expand, and the star becomes a red giant. Even our sun will go through this phase one day. Its diameter will reach 300 million kilometers, engulfing Mercury, Venus, and possibly Earth. But there is an even larger class, red supergiants. For example, Betelgeuse, 1.2 billion kilometers in diameter, 700 times larger than the sun. If it replaced our sun, even Jupiter would not survive. But the largest candidate, UY Scuti. It could contain 5 billion suns, very cool, about 40% cooler than the sun, a red supergiant, but it is nearing the end of its life. These giants eventually explode, scattering elements into space. These elements become the building blocks of new stars and even life itself. So, can stars get even bigger? Maybe. But there are limits. If a star exceeds the so-called Hayashi limit, it becomes unstable and begins to shrink. In the end, these stars are unimaginably massive. But compared to the entire universe, even they are just tiny dots. Galaxies span millions of light years, and the universe itself is beyond imagination. But that doesn't mean we shouldn't try to understand it. And perhaps living on a small planet around an average star isn't such a bad thing after all. It is estimated that there are at least 2 trillion galaxies in our universe. However, this number is not exact, because a definitive answer about the number of galaxies cannot be given without fully measuring the nature and quantity of the cosmic optical background radiation. In the observable universe, there are approximately 225 billion large galaxies, such as the Milky Way or the Andromeda Galaxy, and around 7 trillion smaller galaxies classified as dwarf galaxies. It is estimated that there are between 10 to the power of 22 and 10 to the power of 24 stars in the universe. This estimate is made by determining the average number of stars in a typical galaxy based on its galactic mass, and then multiplying this number by the estimated number of galaxies in the universe. However, this is only an estimate, and it should be taken into account that not all galaxies and stars are of the same size. Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.